Alright, this is a 1000-watt PMA from Missouriwindandsolar. Then I've got my amp gauge and my voltmeter, my battery, which only has about 11.5 volts in it, and then I have a stock alternator. These are both Chevrolet style alternators. What I'm going to do is I'm going to show you what this can do, putting into here, which is about 14.5 volts, putting in 21 amps at, I'm not sure the RPM yet, I don't have an RPM gauge. But I'm going to give you a show on that, and then I'm going to show you what that permanent magnet rotor will do in a stock alternator. The windings in here I have replaced with some aftermarket ones I got from the alternator shop. These produce voltage at very low RPMs in an alternator. Now I don't know what they're going to do with this, because I can't tell the RPMs in this yet. But here in a minute I'm going to set it up and show you what it is. Okay, this is my little meter. It goes all the way to 22 amps right there, and the battery is currently at 1181, and I am using a DeWalt drill. On low it's 450 RPMs, on high it's 1500, but this alternator puts out quite a lot of resistance when it's hooked up like this. Let's see what we do on the 1500 watt. We're doing just above 18 amps at 15.5 volts. Let's put it on the 450 setting. We are probably doing 3 amps at just above 12. Now that's with an aftermarket core in it, stator core, that I got from my local alternator shop. Doing some experiments trying to find a good cheap replacement for the one that's in there, and I'm going to let all y'all know what it is. And here next we're going to try the next one. Alright, here we go with I put that rotor in a regular alternator, no other alterations. Let's see what happens. And this is on low on my drill, which is supposed to be 450 RPMs. And I'm not getting jack. Let's raise it up to number 2, which is supposed to be 1500. We're getting about between 14 and 15 amps at 1346 going into a battery. I'm not getting as near as much as resistance out of it either. Like I said, the only difference is I put this in a regular alternator case. So if you was running a motor to charge at camp, I don't think you could use that on a wind generator and get much out of it. It just doesn't. You have to spin it too fast. The other one as well, let me show you what it looks like. The original one that I bought for that, it's a Y-wound stator core, and that's it. It's brand new. It cost me $40. I have sent off the one that came with it, which will do about 80 amps, you know, and 45-50 mile-an-hour winds is what they claim. But I didn't have this test equipment at the time. I've got a RPM sensor for shaft on its way in. When I get that, I'll be able to get more accurate how many RPMs this is actually spinning. I mean, I see people all the time saying, well, this drill is rated for this. Well, it is when it's not under load. That's no load, and that's pretty quick. It was at least 200 or 300 RPMs less than that under load. And that's the battery, the marine battery I had. It ain't even a good battery, but it is low and it will take a charge. And I've got bunches of batteries because, you know, I have a battery shop. Let me show you some other stuff I'm working on. I have my 100-watt panels. These are made for charging 12 volt. I have a charge controller on the way on that. I'm selling those out of the shop. kind of messy. I've been working on that damn alternator all day. Here's my tough book and the computer I built. This is a server board. It's got 2 dual core 1.8s in it. I can go all the way up to 2.8s, but haven't had the money to buy those yet. Power supply. It looks like crap, but it works great. I can put 8 gigs in it. I've only got 4 in it right now. But that's it. I will give you another update when I get back the original stator core. And we will do the same test on it, and I will redo these tests with an RPM, an accurate RPM on it. And the other one's going to overdo that amp meter, so I'm going to have to buy me an amp meter that'll handle more amps than that. Because I'm going to try to figure out the best way for somebody to build this on their own. The hardest part of this whole thing is that rotor. That is one bad son of a bitch. The stators aren't nothing. I mean, you can wind these yourself. Or you can go to your local alternator shop and say, I want this many turns on this, and you know, describe what you want, and most of the time they don't wind them there. They'll send it off to get wound, and it'll cost you between $40 and $75, $80 depending on where you go. Like I said, I got that one. I'm going to have that other one duplicated just to see how hard it would be. I'll get a price on that. I might start selling those. Just the stators. I can't make this. So, but these right here are made in Missouri, and this is made in Missouri. Oh, one more thing. This case has been sprayed with lacquer. Okay, it's okay to spray your windings with lacquer, and it's okay to spray your windings with lacquer and your rotor, but do not spray this with lacquer. And do not spray your case inside or out with lacquer, because it acts like an insulator. That's why these are made of aluminum, because they disperse the heat very good, and you will cause it to burn up eventually. It won't be able to disperse the heat as fast. So just do your rotor core or your stator core and your rotor. It doesn't hurt it to be sprayed with lacquer, but do not spray your rectifier. It has to dissipate heat through this aluminum heat sink, and your case has to dissipate heat. So I will keep you up to date on what I'm doing here. This is kind of a new project for me. I just started my own business and getting into the solar and wind generator stuff. I got a guy wanting me to build him a hydroelectric unit on his dam, so I'll let you know how that goes. I'll video that whole thing. Alright, bye.